So students, so in that same continuation of the optical communication class, in the previous session we started the lasing action. They are considered to be the two process. One is for the stage 1, another is for the stage 2. The stage 1, we've said that we do have a forward bias that is applied to active layer, and it is going to confine the layer from the PN junction, right? From the PN type of junction, when we confine the layers, when we talk about that lasing action, that's gonna happen based on that. Clear? So next thing, how the whole electron pair is going to create and how it's going to recombine. So basically, when we try to combine the whole electron pair in the one direction, so that is going to happen based upon the process, how it's going to work on it. So once it's recombined, that will be going to take care by the lifetime to emit this spontaneous emission. That is also we covered, and we know about the lifetime carrier, right? So what is the lifetime carrier? Whenever we try to find out the carrier time, how much the carrier time is going to take for the rise and fall, if you want to see the both the timing, we can able to find it's this carrier time, right? So the carrier time also we talk about it, and then we proceed with what is the forward bias that is gradually increased because of causing more pair and more emission. So whenever we are putting in a forward bias condition, it is going to take more pair on that. So that means it's going to take more number of forward bias that is gradually causing more pair and more emission. So the emission is also getting increased based on that. Next part, some of these photons are reabsorbed to create more pairs. That means keep on reabsorbing by itself, and it start going for the stimulate pair to recombine before it is going to proceed for the spontaneous carrier lifetime emission for the stimulated emission. That means we have seen in the graphite, for it is going to take first it's going to take with what actually it is going to take the spontaneous carrier, then after that it is going for the stimulated emission for the lasing action. Clear? So the next part, the stimulated emissions increases with the currents. So whenever we give a current, obviously we are giving an external current towards the laser, so obviously it's going to increase the kind of current which we are going to obtain. Next is current at which stimulated emissions completely take over the spontaneous emission. That means at a particular value, the stimulated emission completely take over, means it's becoming the spontaneous emission. That is called it as threshold current. Means at a particular point, your stimulated emission is taking place and it's getting completely spontaneous, completely take over by this spontaneous emission. That is called it as threshold current. Clear? Next thing, as you can see in the graph itself, as we are having the two kind of thing, already I've explained you about that. That is, it's going to take lasing on stimulated emission and the spontaneous LED type emissions. So both the things we are considering here, x-axis is nothing but the current, and y-axis we are taking the relative power. So at the particular value, the relative optical output power we are taking on that. So as you can see, this is a threshold current. At what condition? At ITH, right? What is ITH? At threshold, this threshold value, your spontaneous current is taken into consideration, and that is nothing but your stimulated emission current is taken over by the spontaneous current. At that particular value, whatever the current we are having, that is considered to be the threshold condition. Next thing, based on the threshold condition, we can able to find out its analysis, how it is going to take for the second stage. This is about till first stage, right? We reach out till what threshold current, how we going to get that threshold current in our device. So basically now we are proceeding with the stage 2. That stage 2 says that it tries for sustaining the oscillation to act as a source. Means for the oscillation part, when we consider that is going to be the oscillation end, the light going to generate remain guided. Guided in the sense it's going to take in gallium arsenic active layer for of 3 layers heterostructures that is going to act as a slab waveguides. That is always how you take as a slab waveguides. These two sides of waveguides cleaved perpendicular to the axis. That means it's going to take care of that particular axis, as you can see in the graph, the stage 2. See here, what is the lasing action is taking place. This is our input power we are giving to the laser. That's the active medium we do have, and we are getting the